All right, stats class. This is section 10.1. So let's work on this homework and see what we can come up with. The blank blank is a statement we are trying to find evidence to support. So if you recall, the null hypothesis is the statement of no change or equality. All right. Then we come up with our alternative hypothesis, and that is what we try to find evidence to support. So the alternative hypothesis is what we try to find evidence to support, and the null hypothesis is no change or status quo. All right. So been doing some things this morning. This is actually I've tried to record this a few times already, and so this is going to spin. So I'm experiencing some of the same things that some of you are. So delete your history, your cache, that kind of stuff. I've already done those things, and still having some of these lagging issues and that kind of stuff. Now my computer's also really slow too, so some of y'all have the same. I'm suffering from the same thing you are. So the null hypothesis, no change, right? And it's H sub 0. The alternative hypothesis is what we're trying to find evidence to support, and it's denoted H sub 1. All right. So hopefully this won't spend too long for us. And it's been doing this too. Access not allowed. It says I've started to work in another window, which is not true. I don't know why. It didn't. Okay, it gave me, notice here it gave me, see if 1 is underlined there. It gave me a check mark for 1. So at least it's doing that. So I have to go back in and open it again. Okay. So you may experience the same thing, but it would be more frustrating if it was not giving you credit for the one you just did. All right. If we do not reject the null hypothesis when the statement in the alternative hypothesis is true, okay? So if we don't reject the null, all right, when the alternative is actually true, that is a type 2 error. If we reject the null when in fact it is true, that is a type 1 error. So you see the difference? We fail to reject or do not reject the null when the alternative is actually true, that's a type 2. Or if we reject the null when it's actually true, then it's a type 1 error. The other two possibilities are when it's true, an actual correct assessment. You rejected the null when the alternative is true, and you failed to reject the null when the null is true. Those two things are results that give you a proper assessment of the situation. So, all right. You can go back and pause the video and read that if you need to. That just says what I just told you. And it's going to spin some more. All right, so this, what will happen is this will be a 20-minute video when it should have been 8.5 minutes because of all the spinning. So feel free when it spins like this just to kind of jump forward 20 or 30 seconds and see if we're on to the next question. If we are, you back up. Maybe that's too much trouble, but it's going to spin. It's been spinning on me all morning. And again, we get that thing, but it gave us number 2. So let's go and see, did I already do number 3 too? If I did, I'll just jump to the next one. All right, here we go. Let's see if this is one I've already done here. Looks like no. All right. If a hypothesis is tested at the alpha, that's the alpha equals 0.05 level of significance, what is the probability of making a type 1 error? So if you recall, by definition, the significance level, alpha, is the exact probability of making a type 1 error. So whenever you see this and it says alpha is 0.05, then the probability of making a type 1 error is the same number. It's the same exact number. So here, that's going to be C. The probability of making a type 1 error is exactly the same number as the alpha. And alpha doesn't have to be 0.05, it just is here in this one. So we will continue to watch it spin and sit in awkward silence at times. And there we go. It just said alpha is the probability of making a type 1 error. And we watch it spin some more. Okay, and now we're 5 minutes in when we should be on question 7. But we're on question 4. Well, we're actually on 3, waiting on it to go to 4. So I hope that this helps. I hope that you're moving along in your classes, mine and others, and you will be successful. And hopefully we will all get past this. I know that it is crazy. More and more and more people each day are getting sick, so I hope that you and your family are safe and well. And if you have somebody sick, I hope they get well soon. It's just crazy. And there we go again, losing this window. I don't know why it's doing this. I have not encountered this issue before. Of course, remember the whole world just went online. So that's probably what's going on behind this. Of course, it could be a my computer thing or a my browser thing, but I don't know. So it's actually probably the fact that I'm using a computer at all. It just does crazy things. So it's the force. I'm a Jedi and I'm doing it with the force. I'm making it close. All right, sample evidence can prove that a null hypothesis is true. So look, when we hypothesis test, we don't actually prove anything. We either find sufficient evidence to reject the null, or we don't find significant evidence to reject the null. Remember, we're trying to find evidence for the alternative. So either we have sufficient evidence that says, hey, it supports our null, so let's reject, or supports our alternative hypothesis, let's reject our null and accept our, reject the null and keep our alternative. Or we're trying to find evidence for the alternative. We don't find sufficient evidence to support that, so then we fail to reject the null hypothesis. So here we don't ever prove anything. We don't prove anything. All right. I should have clicked that sooner and talked to you while it was spinning, because I had plenty of time. I could have read you a Star Wars novel in each one of these breaks. Even Lost Stars, which is like 551 pages, but it's excellent. It is absolutely excellent. All right. So again, although sample data can be used or is used, it cannot be stated with 100% certainty that the null is true. All right, let's see. It's going to spin and probably kick us out again, because that just seems to be what it's doing right now. That's the status quo. The null hypothesis is, when we go to the next question, my stat lab will kick us out. The alternative is, it will not. Look at that. And we found sufficient evidence to fail to reject the null. That's a terrible example. Maybe not. All right, so let's keep going through this, and it looks like it's going to be a slow go of it. All right. Again, just when we get to the end of a question, if you want to just kind of jump forward a little bit, it's probably going to work out for you, because we seem to be encountering issues every time we go. All right. But look, we know we can sit here and we may have to spend an extra 30 seconds or a minute between, or 20 seconds or whatever, but we can get through this. It can be done. Determine whether the hypothesis is left-tailed, right-tailed, or two-tailed, and what parameter is being tested. So here, H naught is this is the null hypothesis. H naught is sigma equals 7, and then H1 is the alternative hypothesis, and it is greater than 7. Greater than 7. So let's trash this here and come back. So the greater than tells me it is not, two-tailed is not equal to, okay? Two-tailed is not equal to, because you're either greater to the right or less to the left than it. So you're one side or the other. That's two sides, two-tailed. But if you're greater than on a number line, greater than is to the right, so it's right-tailed. If you're less than, that's to the left on a number line, it's left-tailed. So because of this greater than on the H1, the alternative hypothesis, then it is a right-tailed test. So as we encounter these issues here, you know, a lot of times life is how we look at it. Expectation creates a lot of either anxiety or relief, or whatever you want to say. If you expect to encounter problems, then you don't mind them very much, so go ahead and expect it. And then also look at this not as an obstacle to be overcome, but an opportunity to show what you can do and how you can overcome something. So, you know, right now in the world, a lot of people are looking at a lot of stuff as obstacles, and we can change our mindset a little bit, look at them as opportunities to do some good stuff, either for ourselves or for others, or just overcoming things and being better for it on the other side, because we're going to come out of this on the other side at some point. It may not be how we like it, may be tough, it may be tough on us or our family, but we're going to come out on the other side. So we're going to look at this as an opportunity. So here, what parameter? Sigma. What does sigma represent? Sigma represents the standard deviation. Okay, so it's either going to be mu for the mean, that's the one, and then the bottom proportion there, that's going to be the letter P. So if you see the letter P, that means that we are testing the population proportion. If you see mu, it is the mean, and if you see sigma, it is the standard deviation. A right-tailed test is strictly greater than, like ours is here. A left-tailed test is to the left or less than, strictly less than, and a two-tailed test is not equal to, right? It is not equal to. So we're going to get another one of these here. Look, it went straight there. Look at that. All right. So here the null mu is equal to 120, and the alternative mu is less than 120. All right. So here less than, right? We have less than. Let's see if I can pick a different color, just for the fun of it. Let's pick blue. Look at all the different shades of blue. All right. Less than is going to be left-tailed, right? Less than is going to be left-tailed. So pick my mouse over here, and we'll pick left tail because it's less than. And then we'll move on to what parameter is being tested. So right here, if we look at this, the parameter that's being tested is mu. So that's going to be what? Mu is the mean, right? Mu is the mean. Sigma is right, standard deviation, and P, we said P is going to be that population proportion. So here mu is being tested, so the mean is being tested. All right. So just go ahead and go back to this real quick, and this. Well, there we go. So mu is being tested. Let's pick it, and oh, look, it went straight there. I was going to do something else while it spun, but it didn't spin. All right. So here again, just to reiterate this. Left-tailed is less than, two-tailed here is not equal to, and then right-tailed is greater than. Okay, just so you know that those three things there. Left-tailed is less than, right-tailed is greater than, and two-tailed is not equal to. So for this one here, this is not equal to, right? This one is not equal to, so this is two-tailed. All right. So let's check this one, and while we're doing that, let's go ahead and get rid of this. All right, and we'll wait on it. So what's being tested here? Well, if I look at this, sigma is being tested, and I just kind of marked through it there. All right, but if sigma is being tested, then that is the standard deviation. In fact, the population standard deviation, to be exact. All right. So this video is turning into something that is very lengthy because of all this spinning. Like I said, we're going to be in that 20-minute range probably for this one. It should have taken 12 minutes, 11 minutes, 10 minutes, something like that. So, but again, an opportunity to persevere, build character, that kind of thing, right? So when I was an administrator, that's what my boss told me. He said, this is a growth opportunity. I said, I'm tired of growing. All right. So then sigma is not equal to 120, two-tailed, and sigma is the standard deviation. All right, that went through pretty quick. That's good. Go to the next one quickly. Yes. All right. So here, 3 years ago, the mean price of an existing single-family home was $243,719. A real estate broker believes that existing home prices in her neighborhood are higher. So a couple things here. We have higher, we have mean, and we have this number here. And I will say that I've done this a few times, and I've seen several students over the semesters do this. I have not seen anything other than 243,000 with some numbers after it. And it might all be in the 700s. I don't remember if it's the last two or the last three that changed. But either way, I think it's just the last three numbers that change. So determine the null and alternative hypothesis. So here, the null hypothesis. So we are talking about the mean. So we want to pick mu. We don't want to pick sigma or p, mu. And then here, the null hypothesis, remember, that is the statement of no change. It is always an equals. It never is anything else. It is always an equals. And then we put 243,719. And then the alternative, mu, is, we circled the word higher. So that's greater, right? We circled the word higher, okay, right above the A in our problem there, right? And then it's going to be the same, 243,719. So we're going to check our answer. And while we're doing that, I want to take away the stuff that I notated on here, right? So, but higher. If it had been lower, we would have used less than on alternative hypothesis, all right? Choose that again. Let's go to our mouse. And let's go ahead and talk about it, a type 1 error. So a type 1 error is when you reject the null hypothesis. So that means we would say, hey, we've concluded that that the price is not 243,719, okay? When in fact it really is, right? So reject the null hypothesis when the null is true. So we have found evidence to say, hey, reject the null when in fact the null is true. So let's see how they word it. But that's the thought process we go through. So here we're going to reject. So we don't want B or C. We reject. So it's either going to be A, reject, or D, reject. Okay. So A says the broker rejects the hypothesis that the mean is this when that is the true cost. That sounds pretty good. Here, the broker rejects the mean when the true mean is greater. If the true mean was greater, we should have rejected it, right? So that's not an error. So here, this is an error. The broker rejected the null. That's the price is this number, right? When the true mean is actually that number. So that is a type 1 error right there, A. And then a type 2 error is when we fail to reject. So we failed to reject the null when the alternative is actually true. So in this case, we fail to reject the null when the true price is actually higher. Okay? We fail to reject the null when the true price is higher is going to be the answer to the next one, depending on how I say it. But that's the thought process. So here, fails to reject is B or C. When it's the true mean cost, nope. When it's greater, there we go, that's it. It's going to be C, right? The broker fails to reject, and the mean price is greater. So that's a type 2 error, and boom, good job. Next question. All right, so here, this is important. Suppose the null hypothesis is not rejected, okay? So here, suppose the null, let me pick a different color. Let's go with some green. All right, so the mean price was this, and it's decreased, okay? But suppose the null hypothesis is not rejected, okay? So if it's not rejected, what are we looking for evidence for? We're looking for evidence to say, hey, the mean price has decreased. So we say there's not sufficient evidence, okay, to say that it's decreased. There's not sufficient evidence to say it's decreased, or there is sufficient evidence to say that it has not changed. So the null hypothesis is not rejected. We find sufficient evidence to reject the null. There is not sufficient evidence to not reject it. So let's look and see what it is here. Suppose the null hypothesis is not rejected. So that means we did not find evidence in support of our alternative hypothesis. So there's not sufficient evidence to conclude that the mean price of a single family home has not, there's not sufficient, so it has decreased. So because we're, again, B here says, look, when I look at B, it says has not changed. That's telling me that I'm finding evidence about the null. This is telling me I'm finding evidence about the H1. So that's A is the one I want to choose and hope that it's going to be right here. Because this one, as you can tell as we talk through it, you got to think pretty hard about it here. Okay. Spinning, this is a scary spin right here because again, this is one that is more thought-provoking than others, and I may have missed it here. We'll see. See, with the spinning going on, typically when it spins, you're right. Good job. There we go. Excellent. All right. So sometimes when it goes straight, or usually when it goes straight to the answer, it's not right. So, but in this case, the spinning is so prevalent that either one could happen. All right. So again, the reason that's the case on A, we look for evidence to say it's changed. There's not sufficient evidence to say that it has decreased. That's why we keep the other one. We don't, for not sufficient evidence to conclude that it has not changed, that means we're looking for evidence to say it hasn't changed. We didn't do that because the statement of no change is a null. You with me on that? So I hope this helps. This is section 10.1. I did all 9 homework problems trying to help you there, especially talking through some of these. So, wait, what happened? Oh, wait, did we skip something? It says, let's look at this. Did we skip something because it says 8 of 9 points? Oh, let's go back and look. Everything is check marked. Everything is check marked. So I think I did everything. All right.